Now, in today's lecture, we will discuss three topics. The topic number one, which is the green chemistry and the sustainable development. Then topic number two, which is the waste prevention and minimization of waste generation. And the topic number three, which is the atomic economy. Right? Now, let's start topic number one, which is what is green chemistry. Okay. So, the green chemistry, it is a design of chemical product and processes that reduce or the elimination of the use of the generation of hazardous substance, right? It is applied across the life cycle of the chemical product, including its design and its manufactures, its use and ultimate disposal, right? So, it is also known as a sustainable chemistry. Okay, for better understanding, one figure are given. So it is a green chemistry, it is also known, it is a green catalyst, then it is a green solvent, then it is a green and renewable raw materials, and it is a efficient processes. So basically they are environmentally begin products, right? So this is the green chemistry. This is all about the green chemistry, right? Now the next topic, which is the principle of the concept of the green chemistry. Okay, so here the lots of principles are given. The first one, which is the prevent waste. Okay, what do you mean by prevent waste? It means that design a chemical synthesis to prevent a waste, right? So leave no waste to treat to clean up. So how this way we can prevent the waste. Then the second one, which is the maximize atom economy. Okay, what do you mean by atom economy? In the next topic, we discuss the atom economy, right? So the design a synthesis so that the final product contain the maximum proportion of the starting material, right? So the waste few or the no atoms are there. Okay, the third one, which is the design a less hazardous chemical synthesis. Okay, the design synthesis to use and generate the substance with little or no toxicity to either humans or the environment. Then the fourth principle, which is the design of safer chemicals and the product. Okay, so the design chemical products that are fully effective and yet have a little or the no toxicity to human or in the environment. Then the fifth one, which is the use safer solvent and reaction condition. Okay, so it means that avoid using a solvent, then separation agents or other auxiliary chemicals. So if you must use this chemical, can safer ones. Now the next one, which is the 6 number principle, which is the increase energy efficiency. So the run chemical reaction at a room temperature and the pressure whenever possible. Then the 7 number, which is the use renewable feedstock. It means that use a starting material, it is known as a feedstock. They are renewable rather than a depletable, right? So the source of the renewable feedstock is often agriculture products or the waste of other processes, and the source of depleted feedstock is often a fossil fuel like a petroleum, natural gas, or the coal or the mining operations, right? Then next one, which is the avoid a chemical derivatives. It means that avoid using, blocking or protecting groups of any temporary modification if possible, right? So the derivatives use additional reagent and to generate the waste. Now the next one, which is the use a catalyst, not stoichiometric reagent. It means that minimize the waste by using a catalytic reactions, right? Catalysts are effective in a small amount and can carry a not a single reaction many times, right? So they are preferable to stoichiometric reagent, which are used in the excess and carry out a reaction only once, right? Okay, the next one, which is the design chemical and the product to degrade after the use. It means that design a chemical product to break down the inconscious substance after use so that they do not accumulate in the environment, right? So this all are the concept of the green chemistry or the principle of the concept of the green chemistry, right? Now, the next topic, which is the principle of the sustainable development. Okay. So, first of all, we discuss with the definition. It means sustainable development. It is a new or creative way to thinking about the product and the processes that make them. Right. It is achieved by continuous application of the strategies to minimize the generation of the waste. Right. And the main features of the sustainable development, which is the CP is an ongoing process that can be applied to production process, that product or services, or it can be extended to cover the entire life cycle of the product or service. So some cleaner production technique which include the change in the technology, then change in the input material, then change in operating practices, then change in product design, change in the waste use, then change in maintenance, right? And the change in the packaging. So these all are the way to achieve a sustainable development in the cleaner production, right? Now, the main principles of the sustainable development, which is that everyone has to right to healthy and productive life in harmony with nature, right? The second one, which is the present and future generation are equally entitled to this right? Then the third one, which is environmental protection must be seen is an integral part of any development processes. And each country has to right to utilize its own resources then without affecting the environmental beyond its borders. Then the polluter must compensate the damage caused by to the environment, which is polluter pay principles, right? Okay, the economic activities are combined with the principle of acquiring preventive measure for the environmental protection. Then state must cooperate for the environmental protection. Now the next one, which is the elevation of poverty and living standard, then inequity or in the different part of the world are an integral part of the sustainable development. Okay, the ninth one, which is the state must limit and extinguish the unsustainable mode of the production and consumption and enhance the appropriate demographic policies, right? Then the 10 number, which is the most effective way of solving environmental problem, is the involvement of the all interested parties. And the 11th, which is state must develop and encourage the informed participation of the population in the decision making process. It is it means that participatory democracy. Okay, then 12 is a state must develop and implement effective legislation for the environmental protection. Then environmental protection must involve all the social groups. Okay, and the last one, which is peace, development and environmental protection are interdependent and the indivisible, right? So these 14 are the principles of the sustainable development. Now, the next topic, which is the waste prevention and minimize of waste generation. Okay, so how we can prevent the waste and how we can minimize the waste generation. So for that, how we can prevent waste and minimization of waste generation, we are using the 3R method. We can prevent a waste and waste minimization and generation, right? So basically, the first one, which is the reduce. Okay. So it is a best way to manage waste. It is not producing. This can be done by being aware of a new guidelines. Okay. So for that, first of all, we buy product in a bulk, then larger economy size product, then reduce the packaging cost and all and the waste, right? Then avoid over packaged goods, then especially one pack with several materials such as a foil, then paper and the plastic. So they are different to recycle. Then plus you pay more for the package, right? So how this way we reduce the waste. Then the third one, which is the avoided disposable goods such as a paper plates, then cups, napkins, then razors and the lighters, right? Then use electronic nail or main bulletin board. Then use a cloth napkin instead of paper napkins. Then use a dish cloth instead of a paper towels. So these are the some example for the reduce the waste or right. So this way we can prevent waste and minimize waste generation, right? Now the second one, which is the reuse. Okay, so it makes economic in environmental sense to reuse the product, right? So the reuse product in a different way. Use a coffee can to pack a lunch, right? Then sell old clothes, appliances, toys, and furniture in the garage sales or advertise to or donate them to charities, right? Then use resealable containers rather than a plastic wrap. Then use a ceramic coffee mug instead of a paper mug. Uh, then reuse a grocery bag or bring your own cloth bag to the stores. Then do not take a bag from the store unless you need one, right? So these are the example of the reuse. And the third one, which is the recycle. Okay, it is a series of steps that take a used material and processes, then remanufactures and sell it as a new product. Begin a recycling at home, at work. Okay, the first one, which is a byproduct made from the recycled material. This can include a metal cans, the newspaper, paper products, glass, plastic, and etc. They consider purchasing recycled material at work when purchasing material for office supply, then office equipment or manufacturing, right? Then speak to store manager and ask for product and packaging that help cut down on waste, such as recycled product and product that are not overpackaged, right? So this way we can recycle the waste, or we can reduce the waste. Then byproduct made from material that is collected for recycling in our community, right? So these all are the example for the recycling the waste. So this is all about the waste prevention and minimizing of the waste generation. Now the last topic, which is the atom economy. Okay, so what do you mean by atom economy? It is a measure of the amount of starting material that end up as useful product, right? It is important for the sustainable development, and it is a good for economic reason to use a reaction with a high atom economy, right? So the green chemistry, then sustainable development, and atom economy, they are connected with each other, right? Now the atom economy, it means that total molecular weight of the desired product divided by total molecular of the all the reactant into the 100, right? So in economy calculation, you can say reactant or the product because of the law of conservation of mass, right? So the greater the percent of atom economy of a reaction, the more efficient or economic it is likely to be, though this is a gross simplification when complex and costly chemical synthesis are looked at, right? So the many reaction give more than one product, right? And all of them are useful. So it is useful to calculate what percent of the product is theoretically useful, and we call this the atom economy of the reaction, right? So the least waste is the waste that is the higher the atom economy, and the less materials are wasted, then less energy used, so making the process more economic, greener, and the sustainable. So quite simply, the larger the atomic economy of a reaction, the less waste product are produced, and hopeful the waste is easy and cheap to deal with, or even a better some use can be found for these byproducts, right? So it can be defined numerically in words in several ways, all of which amount to the some theoretical percent number. Okay, so here the one example are given. The chemical industry is continuously working on a chemical synthesis route that have the highest atom economy and give the highest percentage of it, right? So the work example are there. First of all, hydrogen can be manufactured by reacting methane with steam, right? So here you can see that the methane plus water H2O, it gives hydrogen, right? 3H2 plus CO. Now calculate the atom economy for this reaction, right? So first of all, the atomic weight for the hydrogen, which is 1, then it is a carbon, it is 12, and the oxygen, it is a 16, right? So here we calculate the molecular weight of the methane, which is here we put the value. So first of all, we put the value of carbon, so 12 plus the 4 hydrogen atoms into the 4 hydrogen atoms. So for that, the hydrogen, it is 1, and the hydrogen atoms are 4. So the 4 into the 1, so the mass of this methane, it is a 16. Okay. Then mass of the H2O. So here you can see that the 2 hydrogen, so 2 into 1 plus oxygen's molecular atomic weight, which is 16. So the answer, which is 18. Now the total molecular weight of the reactant, which is 16 plus 18, because in this side, in the left hand side, the chemical reaction which is CH4 plus H2O. So this side, the total molecular weight, which is 34, right? Okay, so now the atomic weight of the hydrogen, which is 1. So 2, here the 2 hydrogen are there, so 2 into 1 is equals to 2. Now we find a balance here, total molecular weight for the balance equation. So here 3H2, so the weight of the H, which is 2 into 1, and here there are 3 hydrogens, so 3 into 2, which is 6, right? So the atomic economy is equal to total molecular weight of the desired product divided by total molecular weight of the all the reactant into the 100, right? So the total molecular weight of desired product, which is 6, divided by all the reactant, which is 34 into the 100. So the answer will be the 17.6%, right? So the total economy, total atomic economy, which is 17.6%, right? So this is all about the atomic economy, right? So this is all about the today's lecture. I hope you all understood about the today's lecture. Thank you for the watching. Thank you.